Hello and welcome back to lecture 6 of week 9, where we look at this stablecoin debt. And where are we now? So in the previous videos we've seen this Oracle contract and the minting policy contract. And yeah, so especially when I read this minting policy, we saw there's these 3 actions that correspond to minting, burning, and liquidating stablecoins, but this was all from the minting policy's point of view, right? So there's kind of 2 things that are still on the side. First of all, what happens actually in the collateral validator, because whenever the minting policy burns or liquidates, actually there's a collateral UTXO that is being spent. So in that case, not only the minting policy runs, but also the collateral validator is invoked. So we want to look at that script in this lecture. And second, in the Oracle, we saw that there's this NFT that kind of identifies the NFT that identifies the unique Oracle UTXO. And yeah, this one of course also has a minting policy, and this one we will also look at in the second part of today's lecture. So let's start with the collateral. So in this case, there are 2 redeemers, and one of them is here called, one of them here is called redeem, and the other one liquidate. So here this redeem corresponds to kind of the burning action in the minting policy. So the case where you want to sort of redeem back your collateral. And the liquidate is exactly the liquidation as we also had it in the minting policy. Note that here basically there's no, like, this third action of minting, it doesn't exist here, because that means we just kind of deposit the collateral. So we send the UTXO to the collateral validator, but the validator is only run when we spend it. So that's why we only have these 2 here. And then there's again a couple of helper functions. The first one, and we have seen it kind of before, is just a signature check. So that the owner is written in the datum here, as we saw before, and we just check that it's among the signatories in the TX info. Next one is this minted amount. So this just we have also seen a similar function before in the minting contract. So this just takes the from the context the value, which is the kind of the tokens that were minted in this transaction, and it extracts from this using from the collateral datum, the minting policy, and the stablecoin token name. It extracts from this minted amount how many among those were the stablecoins. And then this check stablecoin amount is something that we use to basically compare whatever we got out of here, so the amount that has actually been minted according to the script context, and compare it with what's written in the datum, where we also write the stablecoin amount. So then looking at the validator itself, so yeah, again, note that here, unlike in the minting and in the minting case, we do actually have now datum, because this is like a spending type of validator, and the datum is exactly this collateral datum. And then we have the, as usual, the redeemer and the script context. And again, we have 2 cases corresponding to what type of action we do, so what type of redeemer we have. And so in the redeem case, basically we need to check that the owner from the datum has signed a transaction, and the so this is this part, and that the coins burned equal the coins originally minted against in the UTXO, and this is the second check. And then in the second case of the liquidation, we just need one check, and basically that the coins burnt equal the coins originally minted. So again, same check as above. And here we don't check the signer, because the whole point of the liquidation is that someone else can do it. Okay, so the check that the position is actually under collateralized was already enforced in the minting policy. We saw it here in this check liquidation. And so, because anyways we know that that contract is run as well when we burn tokens, we don't need to do this check here again. So that would be duplicate, and we don't want to do unnecessary execution, which would cost unnecessary transaction fees. So maybe one question that comes up is, if all of these important checks are already done on the minting side, why do we even have a collateral validator? But the point is that still the collateral UTXO must be controlled by some script, right? So if we just use like let's say always succeed validator, then anyone could spend this UTXO without burning anything. So in that case, we wouldn't be sure that also the minting script is run and enforces those important things. So basically the collateral contract essentially says something like, if you want to spend this UTXO and take this ADA, you can only do so if you actually burn some tokens in the same transaction. And this burning then ensures that the minting contract is also executed, and that one in turn enforces those important remaining checks. Okay, so this covers the collateral contract. And then we want to also have a look at this NFT contract. So just to recall, what is this NFT actually? So this NFT is the one that sits in the Oracle UTXO. So we actually check here in the Oracle contract always that this input has a token, and this token is exactly what is in the Oracle parameters, the NFT policy ID and token name. And here this policy ID will correspond to the following minting policy. So here this validator has kind of two parameters that are given at compile time. So this OREF is a specific UTXO reference, and the policy is parameterized on it, so that once we compile it, we get the policy hash that is really bound to some specific UTXO. And after this has been spent, nobody else can ever produce the same policy, so mint from this same NFT again. And then we have the token name, so this is the name of the NFT. And we want each developer's Oracle NFT to be readable, let's say by On-Chain Explorer. And yeah, this just means we can set it as some parameter that kind of gives some clue of what this might be, so that if someone else sees it, they know. And yeah, we don't need a redeemer here, because there's no action that we do except from the initial mint. And then in the validator we have three checks. We have this assert minting purpose, this has UTXO, and the check minting amount. So assert minting purpose is just to ensure that actually we mint. So this is the only allowed action here. Otherwise we fail, basically. The second check is what we just discussed, exactly that this specific UTXO we fix at compile time is among the inputs. Okay, this ensures that later we cannot mint again because it has been spent, and the UTXO, the hashes are unique. And then the last is just this check minted amount. It looks a bit complicated, but actually all it does is that exactly one token of exactly our token name is minted and nothing else. And yeah, about this check mint amount, the kind of subtle point is that so this loop walks through every policy ID in the transactions mint field, right? And for each policy, it inspects how many distinct token names appear there using this line here. We ensure that we basically only flip this valid field when looking at a policy that mints a single token name, including our own basically. And the count, this kind of count tally then ensures that only one policy in the whole transaction is doing any non-zero minting. And so the kind of subtle property here is that this checks not only that we mint one token of the one we want, but it also rejects any transactions that additionally mints something else under a different policy. Yeah, so to briefly recap, we basically have now seen all 4 pieces of the contract. We have this NFT, we have looked at this oracle that uses the NFT inside. Then we have seen the minting policy, which is kind of the core logic of the whole stablecoin, let's say. And then we have seen this collateral that ensures that the collateral is only spent basically when we also execute the minting policy, which then ensures the logic of the stablecoin. And in the next and final video, we will basically discuss the homework and discuss a few extensions that one might do to this stablecoin app to maybe also practice a bit further with the contract writing in OpShin.